Hello, my name is Stefanos Konandreas and I'm the president of Florotech's ASME Year 2000 Student Design Competition, which was entitled The Bottling System. Now, in this year's design, we had to design and manufacture a mechanism which is capable of transporting this standard 1 liter bottle of water 1 meter stations, which they posed on this competition, were the usage of the motors. We could only use this kind of Radio Shack 1.5 volt motors, and the entire mechanism had to fit into this 30 by 30 by 50 centimeter box. Now, the car will proceed forward. You lift up the bottle, and once it reaches the destination, the car will return back to its original configuration, and there's a joint mechanism between the holding and the filling of the bottle, which is connected to this line over here. And once the bottle is filled up with water, the capping mechanism starts and caps the bottle and pushes the water tube out of the way to the left. As you can see now, the bottle's being capped, touches the sensor and starts going back up. As this is going on, the tube is returning back to its original configuration. Because there's a little weight over here, it causes the motor arm to turn back. Now the holder goes out of place, and we have yet again filled and capped bottle. And now I'm standing for the final and complete project, and I'd just like to say that we have come along several designs, and I'd like to emphasize the final design and why we chose certain aspects and certain designs, and I'll go into that now. Well, one of the biggest problems in this design was the breaking down of all the separate components in order to finish up with a filled capped bottle. Now, the first problem was to transport the bottle 1 meter. The second problem was to find a way to lift up the bottle horizontally. The third problem was to fill it up with water, and the fourth was to cap it. And the first designs we established on was mechanism, which is very simple and integrated in the base. And the way it works is it's just a simple ramp, and we use the nozzle of the bottle to penetrate this base so that it can lift itself up as it's being pushed towards it. I'll repeat it. And I put very little friction on my hand. Accompanying the design of the integrated ramp, we had to figure out a way to push the bottle up, because if you simply just push the bottle, you'll get stuck in a toggle position. So we had to smartly design the front of the car so that the bottle will not get stuck. And the first implementation was this part over here. By pushing the bottle from the bottom, you ease up the ramp rather than pushing it from the top, which is a bit harder. And through the development of this, we found out that even though the bottle got up the ramp, this part would get stuck underneath. For example, let's say my hand is this part. See? It gets stuck. So we had to design an extra clip in front of it, which would basically take over pushing over the range of motion as the bottle goes up the incline. So, as it's being pushed, as you can see, this top clip takes over and leaves this behind, since this is in the foreground, and puts the bottle upright into its position. Now, one of the most challenging pieces on this mechanism was the capper. We basically found a helix with roughly the same pitch of the bottle cap in a machine shop, and we decided to build upon that and use it to cap the bottle. And the way we decided to do that is to embrace the outer gear, so to speak, with normal gears in a sort of column configuration, and spin this entire helix gear downwards through this gearbox. So, for example, as you turn this, it therefore turns this column gear in a circular motion, so it goes down. And this creates 2 degrees of freedom. One is downwards motion, and the other one is circular motion, which is the exact motion we need in order to cap the bottle. And once we figured out that, we came into capping difficulties and how we should go about holding the cap as it's being capped onto the bottle and release it as the helix gear goes back up in this motion. And after doing a little bit of research, we came up with this design over here. And if you look closely enough, if you turn this bar in this direction, it will cause these two to close in. Therefore, if you have a cap in the center and you turn this bar in a clockwise rotation, these 2 bars will hold on to the cap as it's being capped, and as you turn the bar in the opposite direction, in the upward, as the helical gear turns upwards, it will therefore turn this bar in this direction counterclockwise and release tension on the cap, therefore leaving go of the cap altogether. And that's the design we came up with, and we found it to be fairly efficient. And another implication which you cannot see in this mechanism, since it's hidden, is an interior suspension system, which I can feel right now. And the reason with which we decided to put an interior suspension is in the case that the cap did not catch the thread of the bottle on as it descends. And through this interior suspension, the cap is able to go into the capper mechanism a little bit until it finally catches the thread and starts being capped. So it allows for about 360 plus degrees until it starts being caught. And that's it for the capper mechanism. Well, as we tested with capping the bottle, we found out that we came up with certain problems. One of which was that the water within the bottle was not enough to counterbalance the rotational inertia caused by the capper. So we had to find out a method of holding the bottle in place as it's being capped. And through several designs, we came across this fairly complex system, which includes holding the bottle and filling it up with water. And one very big advantage with this design is that it is also easily accessible by the capper mechanism, since the filler moves out of place as the capper goes down and caps the bottle. And the way it works is, the second the bottle is lifted up into place, this holder mechanism comes in and wedges the bottle into place, holding it there tightly. And as that goes on, it basically pulls this string, nylon string, and lifts up the cork, allowing water to bypass and go into the bottle. And another small addition was this little lead weight bar, which causes the entire filling mechanism to naturally go into place above the reservoir. And as the capper goes down, it basically pushes this filling mechanism out of the way, does its job by capping the bottle, and as it goes back up, due to the weight and the moment arm, the filling mechanism goes back into place. And at the end, this wedge holder system returns to its original configuration, allowing everything to return back to its original position. This entire track is divided into 4 pieces. And the way we decided to attach them together is by having rubber track fold over onto the other track, therefore wedging each link together. Forming a fairly straight plane for the car to cross over. Another problem which we encountered was the fact that not all bottles had the same dimensions. These 2 bottles, for example, have fairly different dimensions. One is taller and slimmer, and the other one is a bit more rounded off. So the way we decided to go about that is to have a liftable piece over here, so that if we were to use a taller bottle, all that we'd have to do is lift this entire section up so that the top of the bottle would be at the same level with this plane over here, so that the filling and capping mechanism would work exactly the same as if it were elevated down on this plane. So the same exact procedures are used. The only difference is that this whole plane is elevated a little bit so to fit the dimensions of this taller bottle. Well, that is it for now, and in my small briefing I hope to have covered all the most important specifications of this mechanism.